Ever wondered what makes your computer or phone work so fast? The answer lies in a tiny yet powerful component known as a microprocessor. This little marvel can be likened to a miniature brain inside your electronic devices, diligently following instructions and making quick decisions. Now, what makes up this electronic brain? It's a small chip, an intricate mosaic of millions of electronic components called transistors. These transistors are the building blocks of the microprocessor, acting like minute switches that can be turned on or off. Picture this. Imagine a vast cityscape at night, with countless lights flickering on and off. Each light represents a transistor, and each flicker is a command being executed. This pulsating network of lights is a visual representation of the microprocessor at work, tirelessly processing instructions. If you're wondering about the nature of these instructions, think of them as a recipe. Like a skilled baker, the microprocessor reads the recipe line by line, executing each step meticulously. For instance, an instruction could be akin to preheat the oven to 350 degree F. The microprocessor interprets this command and executes it, akin to setting the oven's temperature. Then it moves to the next step, like mix the dry ingredients. The microprocessor triggers the appropriate transistors to perform this action. This process continues, with the microprocessor systematically going through the instructions until the cake is baked, or in our case, the task is completed. And the speed at which it does this is mind-boggling. The microprocessor can execute billions of instructions every second, enabling our devices to perform complex tasks at a blistering pace. It's like having a tiny, incredibly efficient worker inside your device, tirelessly following instructions and accomplishing tasks at lightning speed. So, in essence, the microprocessor is a tiny genius, diligently following instructions. It's the beating heart of our electronic devices, making all the digital magic we see possible. Can you imagine a world without it? We certainly can't. So how does this tiny genius perform its tasks? Let's imagine the microprocessor as a baker, and the instructions it follows as a recipe. Each step in the recipe represents a single instruction, and the baker, or microprocessor, must follow these instructions in order to bake the cake or carry out a task. First, the microprocessor reads the instruction, just like the baker reads the first step in the recipe, say, preheat the oven to 350 degree F. The microprocessor then executes this instruction, activating the necessary transistors inside it, akin to the baker turning on the oven and setting the temperature. Next, the microprocessor moves on to the subsequent instruction. Mix the dry ingredients, as an example. Like a diligent baker, it follows this instruction by again turning on and off the appropriate transistors, which effectively perform the mixing operation. The microprocessor goes through the instructions one by one, executing each step until the entire program or recipe is completed, and the cake is baked or the task is finished. This process is incredibly fast, as the microprocessor can perform billions of instructions in a single second. That's like baking millions of cakes in the blink of an eye. It's like having a miniature yet incredibly efficient baker inside your device, following instructions and carrying out tasks at lightning speed. This is what enables our electronic devices to perform complex tasks quickly, making all the wonderful things we use them for possible. But what about the ingredients for the recipe? Where does the microprocessor get the information it needs to carry out these steps? That's where the registers come in. These are like little storage boxes where the microprocessor keeps the information it needs to carry out its instructions. It's like the baker having a pantry full of ingredients at his disposal. This microbaker is more than just a follower of recipes. It's a multitasking wizard, capable of handling numerous tasks simultaneously, all thanks to its ability to follow instructions with precision and speed. Think of it as a super efficient baker, whipping up your favorite cake in a fraction of a second. Now, let's delve deeper into the workers of this efficient factory, the microprocessor. Picture a bustling factory floor, humming with activity, where every worker has a vital role to play. In the microprocessor, the registers are equivalent to such workers. They are like small storage units, much like the shelves in a factory where important tools are kept. Whenever the microprocessor needs to work with data, The registers are there, holding on to the crucial information, ready to retrieve it at a moment's notice. They're like the diligent workers who always know where to find the right tools for the job. Moving on, let's meet another critical worker in our tiny factory, the arithmetic logic unit, or the ALU. Picture a worker who's really good at math and logic problems. You give them a complex calculation or a tricky problem, and they can solve it in a flash. That's the ALU for you. It's the part of the microprocessor that performs all the calculations and logical operations. If an instruction requires the microprocessor to add two numbers or compare two values, it's the ALU that gets the job done. Imagine handing over a mathematical problem to the ALU. It's like giving a blueprint to a skilled craftsman. The ALU takes the problem, works through the calculations, and comes up with a solution, all in a fraction of a second. It's like having a mathematical genius right inside your device, ready to solve problems at lightning speed. These are the first two key workers in our microprocessor factory: the registers, holding onto the data, and the ALU, tackling the calculations. They are the backbone of the microprocessor, working tirelessly to execute the instructions and make sure your device functions smoothly and efficiently. So these are the first two key workers in our tiny factory. Together, they make the microprocessor an incredibly powerful and efficient hub of activity, much like a well-oiled factory floor, humming with the rhythm of productivity. Every factory needs a supervisor, right? Now let's dive into the role of the control unit in the microprocessor. Just like a supervisor overseeing operations in a factory, the control unit is the part that ensures all the tasks are carried out in the right order. You see, the control unit reads the instructions from the computer program. It's like the supervisor picking up the blueprint of the project. It reads and understands what needs to be done, step by step. Next, it coordinates the other parts of the microprocessor. It's like the supervisor delegating tasks to different workers in the factory. For instance, it might tell the registers, which we can compare to the workers holding important tools, to fetch certain data. Once the registers have the necessary data, the control unit then passes this information over to the arithmetic logic unit, or ALU. The ALU is akin to a brilliant mathematician in our factory analogy. It's responsible for crunching numbers and making logical decisions. So if the instruction is to add two numbers together, the control unit will direct one register to get the first number and another register to get the second number. These numbers are then sent to the ALU, which performs the addition. But the job isn't done yet. The result from the ALU has to be stored somewhere, right? That's when another register comes into play. It's like a worker who's responsible for storing the finished products. The control unit ensures that the result from the ALU is safely stored in the right register, ready to be used for the next step of the instructions. The control unit is like the conductor of an orchestra, ensuring every part of the microprocessor plays its part at the right time, in the right order. It makes sure the microprocessor operates in harmony, following the instructions from the computer program to perform all kinds of tasks and calculations. In essence, the control unit is the boss, ensuring everything runs smoothly. It's this precise coordination that allows your devices to perform complex tasks swiftly and accurately, all thanks to the microprocessor, the tiny, incredibly efficient factory inside your device. Now that we know the workers and the boss, let's see them in action. Picture this. We've got an instruction, a simple one: add 5 and 3. This instruction is a part of a computer program that the microprocessor is working on. Now let's break down how our tiny electronic team handles this task. First off, the control unit, our supervisor, reads the instruction. It understands what needs to be done and starts coordinating the operation. It tells one of the registers, our tool-holding workers, to fetch the number 5. Another register is told to get the number 3. Now that we have our numbers, the control unit sends them over to the arithmetic logic unit, or the ALU. This is our math whiz worker. The ALU takes these numbers and adds them together. It's swift, it's precise. In a blink of an eye, the ALU has the answer, 8. But we're not done yet. The result needs to be stored for later use or for the next step in the instructions. So the control unit instructs another register to hold on to the result. The number 8 is safely stored, ready to be used when needed. And there you have it. The microprocessor just executed an instruction. The control unit, the registers, and the ALU, They all work together, each playing their part, to get the job done. But remember, this is just one instruction. A microprocessor can handle billions of such instructions every second. It's this incredible speed and efficiency that allows our devices to perform complex tasks, to run apps, games, and software, and to connect us to the digital world. So a microprocessor is like a tiny, incredibly fast worker inside your device, following instructions and performing tasks at lightning speed. Whether you're streaming a movie, playing a game, or just scrolling through your social media feed, it's the microprocessor that's making it all possible. It's the little electronic brain inside your device, tirelessly working to bring the digital world to your fingertips.